Welcome back to the Datarekha audio guide. I'm Diya.
And I'm Arjun. Today, 3 ways to make an LLM app cheaper and faster. And one of them will quietly hand a user a confidently wrong answer if you set a single number badly.
Give me the scenario first. When does caching actually earn its keep here?
Picture a support chatbot for 50,000 users. Several hundred times a day, someone asks, "What is your refund policy?" Every single time it hits the model, pays the input token cost, waits a second or two. A cache can collapse that to a microsecond and basically zero cost. And the one number that decides whether it's worth anything is hit rate. 10% hit rate barely moves your bill. 90% cuts it by 90. Everything is in service of a high hit rate.
Okay, 3 catches. Start me with the simplest. And tell me why it pairs so well with embeddings.
Exact match. The key is a hash of the model, the parameters, and the exact input text. Identical bytes in, identical key, instant hit. No vectors, no machine learning, just a hashtable lookup. And embeddings are the perfect candidate because an embedding model is deterministic. Same text, same model. The exact same vector every time. No temperature, no randomness. So once you've computed the vector for what is your refund policy, that 1500 dimensional vector never changes unless you swap the model. You can cache it essentially forever. In a RAG system embedding thousands of documents, that turns mountains of recomputation into a lookup.
There has to be a catch. What does exact match miss?
It's byte sensitive, brutally so. Reset my password and reset my password with one trailing space are different keys. And any paraphrase. How do I change my password? Sales right past. Different bytes. Miss.
Which is presumably the whole reason cache number 2 exists.
Exactly. The semantic cache matches by meaning, not bytes. Instead of hashing the query, you embed it and store it in a vector index next to its answer. New query comes in. You embed that too. Search for the nearest stored query. And if the cosine similarity clears a threshold, return the stored answer. Reset password and how do I change my password embed close together, so the paraphrase finally hits.
And this is the one you want can lie. I want to understand exactly how.
It all rides on that threshold. Set it too low, and you call 2 different questions close enough. Someone asks, "Can I get a refund after 60 days?" And it lands on the cached entry for "What is your refund policy?" and gets back an answer stated with total confidence that doesn't actually address their question. The system isn't unsure. It's wrong and certain.
So is the move just to keep the threshold high, like cosine above 0.95?
That's most of it. 0.95 or higher for most domains. But there's a second move, just as important. Scope the index. So billing questions and technical support questions sit in separate indexes and can't bleed into each other. And use semantic caching only for stable, factual queue and never for personalized answers, time-sensitive data, or anything where the right answer depends on who's asking.
Right. Now the third one, you said it works completely differently.
Totally different beast. Provider-side prompt caching lives inside the model provider, and it doesn't cache the final answer at all. It catches an intermediate computation. One fact about transformers makes it click. As the model reads your tokens, it computes these key value attention tensors for every token. For a 10,000 token system prompt, that's expensive. And it's identical for every request that reuses that same prompt. So the provider stores those tensors and skips recomputing them.
So how do I actually get that win and what breaks it?
Anthropic charges about 10% of the normal input price for the cached prefix, with near zero added latency. You exploit it by putting the stable stuff first. System prompt, tool definitions, shared documents. And the variable stuff, the user's message, last. The provider catches up to the last stable token. Only the small suffix recomputes. The discipline is keeping that prefix byte stable. Any single character change invalidates everything after it. So never inject a timestamp, request ID, or user data into the prefix. That goes in the suffix. The reassurance though, because it only catches the computation, not the answer. The model still generates fresh output every time. Unlike the first two, prompt caching can never give you a stale or wrong answer.
Now I have to ask about the part that scares me, multi-tenant SaaS. 200 enterprise customers, isolated data. I add LLM and A and cache by hashing the prompt. What just went wrong?
And that's the landmine. If the prompt carries tenant-specific data and you hash only the prompt text, two tenants asking the same question produce the same key, and one customer can receive the other's cached response. That's a data leak. It's silent, tests don't catch it, and it has burned real production systems.
So the cache key has to carry identity, not just content.
That's the insight. You namespace by tenant, and by user for anything user scoped. Tenant ID, user ID, model, version, then the prompt hash. The flip side is fine. A shared knowledge base embedding doesn't depend on who's asking, so leave the user out there. The rule is, if the answer depends on who you are, the key must too.
You mentioned versioning twice. Model name in the key, why does that bite?
Because if you upgrade the embedding model, your old cached vectors are now wrong. They live in a different vector space entirely. So you always bake the model name and version into the key. Bump the version, and you get a clean namespace on the upgrade. No poisoned old entries. Same spirit as TTLs. Ask yourself, if I serve this answer 24 hours from now, would it be wrong? A refund policy lasts a week. A live price lasts seconds. Or you don't cache it at all.
So the playbook start to finish?
Exact match first. It's O of 1, 0 false hit risk. Often 60 to 80% hit rate for free. Layer semantic on top for the paraphrase tail, starting strict. Turn on provider prompt caching for your long system prompt, nearly free. Then version your keys, set TTLs, and namespace by user. Two of these speed you up safely. The third trades correctness for hit rate, so respect the threshold.
Cache the computation freely. Cache the answer carefully. That's the Datarekha audio guide. See you in the next one.